Hello everyone, I am Rahul Shandilya and this new lecture of Internet of Things will discuss IoT reference architecture, which is the part of unit third topic. So what actually is a reference model or reference architecture? In the IoT domain, anyone can propose an on architecture and an on communication protocol. Due to a wide variety of requirements to which each architecture should be compliant. Common reference model for the IoT domain and the identification of reference architecture can help to a faster, more focused development and an exponential increase of IoT related solutions. So, a European agency or European Lighthouse Integrated Project has tested for 3 years Internet of Things architecture and created an architectural reference model together with the definition of an initial set of key building blocks. It wants to promote a common ground between architectures so that they can interoperate even in IoT more levels. IoT A has achieved that thanks to two steps, that is reference model and reference architecture. So IoT means IoT A I has two component reference architecture, and the European agency has made a reference architecture which has two part reference model and reference architecture. Based on that, it laid a common ground which helped to uh, select a architecture for particular solution. So IoT ARM consists of the four part. Vision summarize the rationale for providing an architectural reference model for the IoT. Business scenario define requirement provided by the stakeholder that are the drivers of the architecture. They allow architecture to be validated. The IoT reference model, which provides the highest abstraction level for the definition of the IoT A architectural reference model. It promotes a common understanding of the IoT domain. It includes the description of domain, communication, and information model. The IoT reference architecture, which is the reference for building compliant IoT architecture. It provides views and perspective on different architectural aspects that are of concern to a stakeholder of the IoT. So here is in this diagram we can see how this uh, reference model and reference architecture help to get a real architecture. Uh, so we have many existing solutions. In first block, you can see we have many existing uh, architectures and solutions. So, and here we have this reference IoT arm, which has two component, a reference model and reference architecture. And as per the problems and solution objective, the vision and witness, this reference architecture, different reference model plus reference architecture helps to select the best practices and therefore to make uh, a concrete architecture. So IoT information model, this is IoT information model. We will study this in detail later. Use of IoT ARM. So basically, it's not only the use of IoT ARM. Basically, it is the use of say reference architecture. Why we design a reference architecture? The first one is the cognitive aid. When it comes to a product development and other activities, an architectural reference model is of fourfold use. Firstly, it helps to guide discussion since it provides a language everyone involved can use and which is intimately linked to the architecture, the system, the usage domain, Secondly, the high-level view provided in such a model is of educational value, since it provides an abstract but also rich view of the domain. Such a view can help people new to the field to find their way and to understand the spatial features and interfaces of IoT. Thirdly, the IoT arm can assist IoT projects leaders in planning the work at the hand and teams needed. Fourthly, the IoT arm helps to identify independent building blocks for the IoT system. This constitutes very valuable information when dealing with the questions such as system modularity, processor architecture, third vendor options, reuse of components already developed. So the second point is reference model act as a common ground. Establishing the common ground for the IoT encompasses defining IoT entities and describe their basic interaction and relationships with each other. The IoT arm provides exactly such a common ground for the IoT field. Generating architecture. The third point is that it helps to generate architecture, the concrete architecture. The concrete architecture helps you to select real, means helps you to make a real design for your solution. But to get that concrete architecture, we need some initial point to think, and that is the use of this reference architecture. One of the main benefits is the use of the IoT arm for generating compliant architecture for a specific system. This is done by providing best practices and guidance for translating the IoT arm into a complete architecture. The benefit of this type of generation scheme for IoT architecture is not only a certain degree of automation in this process and thus lower R&D effort, but also that the decision made follow a clear documented pattern. Identified difference in derived architecture. The IoT arm defines a set of tactics and design choices for meeting qualitative system requirements. All of these facts can be used to predict whether the derived architecture will differ and whether they will do. The IoT arm can also be used to reverse mapping. System architecture can be cast in the IoT arm language, and the resulting translation of the system architecture is then stripped of incompatible language and system partition and mapping. The difference that remains are the true difference in architecture. The next point is achieve interoperability. By comparing the design choices made when dividing two architectures, one can readily identify where in architecture measures are necessary to achieve interoperability. Interoperability may be achieved a posteriori by integrating one IoT system as a subsystem in another subsystem, or by building a bridge through which key functionality of the respective other IoT system can be used. System roadmaps and the product lifecycle. The IoT arm can be used to devise system roadmaps that leads to minimum changes between two product generations while still guaranteeing a noticeable enhancement in system capability and features. This approach also helps the designer to formulate clear and standardized requirement-based rationale for the system roadmap chosen and the product life cycle that result from the system roadmap. And then next one is the benchmarking. Benchmarking means we are comparing different architecture and then finding which one is the best for which say parameter or for which solution, which architecture is best. So while the reference model prescribes the language to be used in the system architecture to be assessed, the reference architecture stated the minimum functional requirement for the system architecture. By standardizing the description and also the ordering and delineating of system components and aspects, this approach also provides the benchmarking process with a high level of transparency and inherent comparability. So this is the basically the summary of how what is system architecture and how system architecture helps to get a concrete architecture, and that concrete architectures result in the real system, helps you to design the real system, helps you to select the components necessary to uh, fulfill to achieve the objective that you have set for your IoT system. So in this next part of next two video, we will basically discuss two type of reference architecture for the IoT. One is the IoT ARM, and another is the World IoT Forum IoT architecture. IoT ARM one is a more detailed one and complete one, but it is little abstract, and the reference architecture designed by the World Forum IoT Forum is a simple and plain, just like the OSI communication model. So meet you in next lecture. Goodbye.